In this chapter, we'll talk about amines and their reactions and amides and their reactions. We're going to start with amines. Amines, they are derived from the simplest form, which is ammonia. And ammonia is normally used as an organic solvent. It's a solvent that is used in the reactions, and this solvent is considered to be a base. The reason why it's a base because of the lone pairs around the nitrogen that makes it electron rich. Now, these lone pairs in there are considered to be a group. So if you want to consider the hybridization of this nitrogen, it has 4 groups around it. So the hybridization is going to be an sp3 hybridization that is going to make it a tetrahedral geometry. And with respect to the shape, because the shape is always affected by the lone pairs. So if the lone pairs are present, they are going to squish these bonds and make the bond angle less than the tetrahedral ideal bond angle, which is 109.5. So the bond angle here is going to be around 107, and the shape is going to be trigonal pyramidal. Okay, so if we want to draw the arrangement of the groups around the nitrogen, they're going to look like this, with the lone pairs over here, and the bond angle is going to be 107 degrees, which is going to be deviated from the ideal 109.5 tetrahedral angle. And the reason why? Because of the lone pairs. There are different types of amines, ranging from primary, secondary, or tertiary. All amines need to have 3 groups around them and the lone pair. So if you have an amine having a carbon chain, just one carbon chain, whether it's a carbon, 2 carbons, 3 carbons, it doesn't matter, and 2 hydrogens, then we're going to call this a primary amine. Okay? If the amine is connected to 2 carbon chains and the hydrogen, then that is called a secondary amine. And if the amine is connected to 3 carbon chains, no hydrogens in there, then this is going to be called a tertiary amine. Okay, all amines are bases. The reason why they are bases because of the lone pairs. So all of these are examples of good bases. Okay, and we know that a base normally is an electron rich, and the way that we represent an electron rich molecule is by the presence of the lone pairs. When nitrogen has 4 groups around it or 4 bonds around it, no lone pairs, then in this case we're going to call it an ammonium ion. So if you have a nitrogen with 4 hydrogens around it, no lone pairs, that is called an ammonium ion. Okay, and if you take the hydrogens out and replace them by simple R chains, then in this case we are going to classify this nitrogen, since it has 4 R's around it, that is going to be a quaternary ammonium ion. And normally we represent it by 4 in a circle. So you have a primary, you have secondary, you have tertiary, and you have a quaternary. A quaternary nitrogen is a nitrogen that is connected to 4 carbons in there. Okay. Now, these 2 examples of nitrogens with a positive charge, those are considered to be examples of acids. So as you can see, by changing the formula charge on the nitrogen, so when nitrogen has 3 bonds and the lone pair, the formula charge is 0. Versus when the nitrogen has 4 bonds around it, the formula charge is positive. We can change the identity of the nitrogen from a base to an acid. So an acidic nitrogen is a nitrogen that has 4 bonds around it and a plus charge. that plus charge is important to make those nitrogens an acid. If you want the nitrogens to be a base, then you would need to have them having lone pairs. Nomenclatures of amines, we do have primary, secondary, and tertiary amines. And each classification of amines has its own method of naming. So let's start with the simplest, which is the primary amine. The rules for nomenclature are kept always the same. So you always have to choose your functional group in there and see what type of functional group do you have. Here we do have an amine functional group. Know what type is this. This is primary amine because the nitrogen has one R group connected to it and two hydrogens. So I know that this one is a primary amine. Okay, so you have to know the type of the amine before you go ahead and start naming it. So to name a primary amines, we are going to choose the longest carbon chain that is connected to the nitrogen. I said the carbon chain. And make sure that that carbon chain basically includes all the carbons that you can fit in there, and especially the ones that are connected to the nitrogen. Okay, so this is going to be the long carbon chain, and then you're going to give the amine the lowest number possible. So you're going to start numbering from the carbon that is connected to the amine. So this is going to be 1, 2, 3, 4, 5, and 6. Now, in order to name the structure, all what you need to do is just name that alkane chain. I know that this one is going to be a hexane. So you are going to drop the E, okay? And then you're going to add an amine. You cannot keep the E because the amine starts with simply an A over here. So the amine starts with an A. This is why you cannot have two vowel letters that are next to each other. And the name is going to be hexane amine. Okay, it's very simple. Drop the E, add amine. That is going to be for the primary amine. So always know what type of amine you are working with. So here I'm going to choose the longest carbon chain that has the amine, okay? I know still that this one is also a primary amine. Why it is a primary amine? It's a primary amine because I do have a nitrogen, and that nitrogen has two hydrogens and it's connected only to one carbon. So this is why it's a primary amine. I choose my longest carbon chain and I give the amine, the carbon of the amine, the lowest possible number. This means that I would need to start numbering from here. So my amine is now on carbon number 3. Okay, notice here that my amine was on carbon number 1, so I did not say 1 hexane amine. Okay, drop the 1, don't say 1 because the name will be wrong. So don't say 1 hexane amine, because if you do this, the name is going to be wrong. Make sure that you drop the 1. However, if the amine is on any carbon of the chain other than carbon number 1, you have to mention where the location of this amine is. So you have 4, 5, 6, and 7. A 7 carbon chain is a heptane. On carbon number 3, I do have my amine. So the name here is going to be 3-heptane amine. Okay, the 3 now is a must. If your amine belongs to a cycle, then in this case, what you need to do is simply, again, the name is going to end in an amine because amines are higher priority than alkanes. Okay, so the name here is going to be, I know that this is a cyclohexane over here. So it's going to be a cyclohexane, drop the E and put an amine. So the name here is going to be a cyclohexane amine. Okay, so see, I dropped the E between the cyclohexane and an amine. As simple as that. And this is still a primary amine. Okay, so that is a primary amine. Just put a note that amines are higher priority in naming than the alkanes. This is why your ending is always going to be in the amine. Okay. For this example over here, I'm still working with a primary amine. So we apply the rules. We choose the longest carbon chain that has the amine. I can go this way, I can go this way, it doesn't matter, but I would need to give the amine the lowest possible number. So that's going to be 1, 2, 3, 4, 5, and 6. My amine is on carbon number 1, so I don't have to mention the 1 in there, but I have to mention the methyl on carbon number 5. This is a substituent, so my name is going to be 5-methyl, and then it's going to be hexane amine. Okay. Now, in order to name secondary and tertiary amines, so notice it's two rules: naming primary amines, naming secondary and tertiary amines. The secondary and tertiary amines, they do have a substituent in there, or do have more carbons on the nitrogen than the primary amine. The primary amine had only 1 carbon in there. So I can easily choose my longest carbon chain. So for the cyclohexane, this is my longest carbon chain in there with the 6 carbon cycle. But for the secondary and the tertiary amines, you do have 2 R groups connected to the nitrogen. So in this case, what we need to do is we have to differentiate between those 2 R groups in there. And we're going to use the prefix N for any alkane substituent. Now, the substituent is the one that is less carbon chain. So here, notice I have on the nitrogen, I have 1 carbon on the side, and I have 1, 2, 3, 4, and 5 carbons on the other side. So the 5 carbons are going to be my ending in this case. Okay, so my ending is going to be the pentane amine, and that 1 carbon is going to be a substituent on the nitrogen. So I'm going to give it the prefix N in there. Okay, so that substituent, that carbon substituent is 1 carbon. So I will give it the prefix N, and I would say that this CH3, this carbon belongs to the N. So I'm going to give it the name N-methyl. And then I'm going to go to the other side of the secondary amine, and I'm going to choose the longest carbon chain. That, of course, includes the nitrogen in there. And then I'm going to give that nitrogen on this chain the lowest possible number. So this means that I have to start numbering from here, and that is going to be carbon 1, 2, 3, 4, and 5. Notice what I said, that I need to give the nitrogen on this long carbon chain the lowest possible number in there, making sure that I number all the carbons in that alkane chain and choose the longest carbon chain in there. Okay, so the name here is going to be N-methyl, and I know this is going to be a pentane, so the name is going to be pentane amine. I'm going to drop the E for the pentane and put an amine next to it. So it's going to be a pentane amine. Okay, notice that I did not say N-methyl. I dropped the 1, so I didn't say 1 in there. I didn't say 1. I dropped the 1. This is pentane amine. And the reason why I dropped the 1 in here, because I don't need to put 1 when the nitrogen is on carbon number 1 of the longest carbon chain. Okay, let's have another example. So again, knowing the type of the amine is very important when you are naming. So this nitrogen is connected to 2 carbons in there. Then this is going to be, again, a secondary amine. This is a secondary amine, and that is a secondary amine as well. Okay, secondary amines always start their naming with 1 N. This is how you differentiate a secondary from a primary from a tertiary. So here I do have the smallest carbon chain is a CH3. It belongs to the nitrogen. So my name here is going to be an N and a methyl. And then I'm going to move by the rule that says, like, choose the longest carbon chain. Okay, that is connected on the other side of the nitrogen. Notice here, I did not choose 1, 2, 3 carbons. I chose the 4, all of them. So you have to choose the longest carbon chain and then give the nitrogen on that chain the lowest number possible. This means that I would need to start from numbering from this side. Okay, so this means that now the nitrogen is on the second carbon in there, on the second carbon. The N-methyl always is going to be the start of the name. So I cannot start by any number. I need to start by N and showing on the side of the nitrogen with the smallest chain first, and then move on to the next side of the nitrogen with the longest chain. Now I know that this is a amine or butanamine, and the nitrogen is on the second carbon of the chain. So now the number is very important to show that the nitrogen is on the second carbon. So I would say 2, and I would say butanamine. So this means that your amine is on the second carbon. Okay, let's have another example in here. This is still a secondary amine. I do have a chain of 2 carbons versus a chain of 1, 2, 3, 4, 5, and 6 carbons in there. Then I'm going to start my numbering from the chain of 2 carbons, or start my name from the chain of 2 carbons, locating that the ethyl group is on the nitrogen. So I would say N dash and then the ethyl, and then move to the longest carbon chain in there and give the nitrogen the lowest number. So this means that I have to start numbering from here, giving the carbon of the nitrogen, carbon number 3, versus numbering from this side and giving it carbon number 4. So that is going to be 1, 2, 3, 4, 5, and 6. So that is going to be a hexane amine or a hexane amine. And your nitrogen is on the third carbon. So the name is going to be 3-hexane amine. Okay, so that is how to name secondary amines. Now, in order to name tertiary amines, we will follow the same rule, naming those small substituents on the nitrogen first. So this is a CH3, it's an ethyl group that is a CH3 in there. And then you have your long carbon chain. So that is going to be my long carbon chain. So start with the small R groups first on the nitrogen, and then if they are different, you're going to arrange them in alphabetical order. If they are the same, you're going to use the prefixes di, tri, tetra, so on. So the name over here, I know that I have an ethyl group on the nitrogen and a methyl group on the nitrogen. Okay, those are different. E comes before the M. So I would say each one will take an N because both of them, they belong to the N. So the name is going to be N dash ethyl, okay, and then N dash methyl. I cannot drop the N because if I drop the N in there, I don't know where the ethyl and the methyl are. Here it's telling me that the ethyl is on the nitrogen and the methyl is on the nitrogen. Notice here I have 2 N's. 2 N's means I'm working with a tertiary amine. So this amine here is a tertiary amine. And then I move on to name the third R group, which is the longest carbon chain, and that is going to be part of my ending. I am going to give the carbon that is connected to the nitrogen the lowest possible number. This is 1, 2, 3, 4, and 5. Paying attention that I have a 5 carbon chain in here. So that is going to be a pentane amine. So my ending is going to be a pentane. Drop the E. Here you go. It's a pentan amine in that case. So each R substituent takes N. Same idea for this example, just know the identity of the nitrogen that you are working with. So this nitrogen has what? It has a methyl group that is connected to it. It does have a phenyl group. This is a benzene, and benzene, when it is a substituent, we call it a phenyl group, okay? And then it does have a chain in there, and that chain has 1, 2, 3, 4, 5, 6, 7, and 8 carbons. So that is going to be an octane. I am going to start numbering to give the carbon on the nitrogen the lowest possible numbers: 4, 5, 6, this is 7, and this is 8. And then I'm going to name, giving each of these R substituents. Let's use a different color. So I have a CH3, which is a methyl in here, and then I have a phenyl in there. The M comes before the P, so I have to arrange in alphabetical order, and the name is going to be N methyl, and then another N and the phenyl in there. I don't use benzene. Don't use benzene, guys, because when benzene is a substituent, we call it a phenyl group, not a benzene. And then on carbon number 2, I have my amine. So on carbon number 2, this is going to be my amine, and my longest carbon chain is octane. So that is going to be 2-octane. Drop the E and put a word amine at the end. So it's going to be 2-octane amine. Now let's say, for example, if you have a chain with 2 functional groups, an amine and another functional group in there, then please look at this table. You can have this one in the exam. Look at this table, guys, and see your priority. Alcohols are higher priority than amine. This means that the ending is always in the alcohol versus the amine, which is considered to be a substituent. If amine is a substituent, we are going to call it an amino in there. So we're going to choose the longest carbon chain as usual, and that longest carbon chain should contain all the functional groups. Since my OH is my highest priority, then I would need to number so that I can give the OH the lowest possible number. This is a 3, 4, 5, 6, 7, 8, and 9. This is a chain, which is a nonane. So this is going to be a nonane. We know that to name alcohols, you drop the E and simply add an OL, okay? And I know that on carbon number 3, I have my alcohol, so I named my alcohol part. And then now all I need to do is just name my amino in there. And I know that this is a 7 and it's an amino. Put a dash in there. So let's write the name right. That is a dash. And this is the amino. And you do have 7 in there. Okay, you do this if you have the amine lowest priority than the other functional group, then that is going to be considered a substituent and you name it as amino. This is a primary amine, but again, the name did not go at the end with the amine because the OH is a higher priority. Let's have another example here. This is a tertiary amine. So it's very important whenever you are naming your amine to know the identity of the amine that you are working with. Now that tertiary amine has what? Has 2 methyl groups that are the same, and both they are on the nitrogen. So I'm going to start the name with an N, and whenever your groups are the same, you are going to group the N's in there. So you're going to put a comma and you're going to put another N. The presence of both N's is a must with tertiary amine. And this is how you can differentiate primary from secondary from tertiary. Primary, when you name it, there's no N's. Secondary has 1 N and tertiary has 2 N's. So pay attention to that. And that is going to be a dimethyl. And then I'm going to choose my longest carbon chain. So that is going to be my longest carbon chain on the other side. And I'm going to give the nitrogen the lowest possible number. So that is going to be 1, 2, 3, 4, 5, 6, and 7. Pay attention, I have to name all the substituents in there. So I know that on carbon number 2, I have a methyl. Substituents come first, okay? And then I do have the rest of the chain in there, which is 7 carbons. It's a heptane. Drop the E and add an amine. So that's going to be a heptane, amine. Okay? No need to say 1 in there. So don't say 1, drop the 1. Because if you don't say 1, this means that the nitrogen is immediately on carbon number 1 of the chain. Now, if the NH2 is attached to the benzene, so you have your NH2 attached to the benzene, the whole thing, we're going to call it, we're going to call it an aniline. And when it is there, we're going to use it as a common root. This is a primary amine. So that is going to be used as a common root in there. And that is going to be always carbon number 1 in the benzene. This is an example of an aromatic amine. And aromatic means I do have an alternation of a double bond, single bond, double bond, single bond. All of those are in a cycle. Okay, let's have an example. So over here, what I have is a benzene that is connected to the nitrogen. It doesn't need to be 2 hydrogens in there. The moment I see a benzene with a nitrogen, I can call this as a common root, and this is named aniline. But anilines can be primary, they can be secondary, and they can be tertiary. So this is why I need to follow the rules when I have a secondary and a tertiary amine, how to name them. It's exactly the same way as we talked about, and you have to use the prefixes, the N prefixes, 2 N's for the tertiary, 1 N for the secondary. So this one is going to be a secondary amine. So I'm going to start by naming the ethyl first. Okay. So I know that this one is going to be an ethyl, and it's going to be an aniline. Okay. So that is going to be your ending in there. It's going to be ethyl and aniline. So it's going to be an ethyl, aniline, and the ethyl and the ethyl on the aniline, this belongs to the nitrogen. So the ethyl is on the N. And then you have your substituent on the benzene. So your substituent on the benzene is where? Here I do have a 1 because the numbering always starts from the common root, and the common root here is the aniline. So you have to start numbering from there. That is going to leave the ethyl on carbon number 4. So you guys have 2 options. Either you say 4 ethyl, and then N-ethyl aniline, or I know this is a 1,4 substituent on the benzene, so that is going to be a para-ethyl N-ethyl aniline. Okay, you use either 4 or para. You cannot use both. So you cannot say para and 4 because para means 4. Okay. Let's have another example before we end this section for a tertiary amine. So let's say if I have a benzene, and on the benzene I have an N, and I have a CH3 here, I have another CH3 there, and then I have a CH3 over here. Then the name is going to be, again, aniline, because aniline is a higher priority than toluene. Okay, so this is a CH3 with a benzene is toluene, and N with a benzene is aniline, and aniline is a higher priority than toluene. Pay attention to that. So this means that my common root, I'm going to highlight it now, it's the nitrogen with the benzene. So immediately the carbon that is connected to the nitrogen is going to be carbon number 1. I'm going to move along the cycle and give the second substituent the lowest number. So the CH3 is going to be on carbon number 4. Okay, now I'm going to name my ending, and my ending is going to be in, this is a secondary amine. So that one is a secondary, I'm sorry, it's a tertiary amine. It's not a secondary one. So this one is a tertiary amine. So my ending here is going to be in the NN dimethyl. So that is going to be N N. It's a dimethyl. And of course, the ending is aniline. So by doing this, I named these portions. I named the benzene, and I named the 2CH3s and the nitrogen. All I need to do now is just name the substituent on the benzene. Here I do have either 4-methyl or I have para-methyl. Whatever you choose, I'm just going to go ahead and choose the para-methyl. Okay, and then N-dimethyl-aniline, because guys, remember, as I said, that aniline is a higher priority in naming than toluene. So this is why your ending has to be in aniline instead of toluene.